Hello everyone, my name is Tarek Mateen. I'm a rising senior in Maryland, and I spent about the last 8 months or so researching automation or artificial intelligence as a part of a research class at my high school. I started off knowing almost nothing about artificial intelligence. I had some robotics experience, and I knew about control algorithms like PID to make it do stuff on its own. So I started researching that. I started researching PID. I was like, what is this? How is it used? But then I stumbled upon machine learning, which was used to tune the PID algorithms. And as I did more research, I found AI, and I found that AI was superior to these algorithms and more widely used for controlling and automating tasks. So I started researching AI in general. I was very blessed to be able to get interviews with the AI experts at University of Maryland, Baltimore County. And while I'm still no expert at all this, as the school year comes to an end, I was tasked with making a final product, and I decided to make a video just sharing my research, my thoughts, what I know. So I'm making this video. In this video, I'm going to discuss why AI is important, how it works, trying to give a summary. So I'm going to talk about the limitations of the technology, which was the main focus of my research, and I'm going to talk about what might happen as this technology progresses and more people use it. The majority of the information in this video is my interpretation, some of it's speculation, so take it with a grain of salt. So what makes artificial intelligence different from all the other technologies, you may be asking? Well, the goal of the field of artificial intelligence is to make a sort of a brain or emulation at the same level or more capable than the human brain. So if a perfect AI is practically human, we must then ask what makes humans special. And while there are many right answers, the one I like can be realized by looking at the device you're watching this on and everything around you. And that description is that we humans take things of little value and find ways to increase their value for us. For example, a bunch of raw materials aren't very useful, but a smartphone, a car, an airplane, or anything made from those raw materials is very useful. So by taking things of little value and increasing their value, we're able to change our lives and the world. The ability to put together something that did not exist before is commonly known as creativity, which is an aspect of intelligence. And all of us are directly or indirectly fueling this process or taking part in this process. If you're mining materials or farming, you might be fueling this process. If you're designing products, manufacturing them, selling them, you're in the center of the process. And if you're in government, education, healthcare, and all these other fields, you're running society and making sure this process continues. And as a result of this system, each individual ideally creates more value than they consume. And that allows us to attempt innovation like, colonizing Mars. To make an emulation or copy of a human, we must first understand humans. And when we study humans, we find that they collect information about the universe using their eyes, ears, mouth, nose, hands. They have tons of skin receptors, taste buds, a lot of ways. And they take this information and process it in their brains. Then they act using their arms, legs, the muscles, their sweat glands, vocal cords. And with today's technology, we have a bunch of sensors, like microphones, cameras, heat sensors, pressure sensors, and we also have tools that allow us to create motion, like motors, pistons, speakers, even artificial soft muscles that allow us to, take action. And while our technology is way behind the biological systems that we have in us, they allow us to replicate the key human features or key biological features in a way where we have more control over it. The difficult part to emulate is the brain, and while we have computers that can do almost anything, the difficult part is programming those computers to take that input, process it, and then act in a way that emulates humans. So the field of AI is trying to answer the question, how can we program computers to emulate the brain. Before diving into what will happen as we get closer to achieving this goal of the field of AI, let's discuss how close we really are to having a computer emulate the human brain. Today, AI is widely used from spam filters to social media algorithms to self-driving cars and airplanes to all kinds of stuff, search engines. And going forward, they're going to be used more and more in education, in medical diagnosis, investment analysis, and even more applications. But does AI being able to do those tasks signify that AI has reached the level of humans? Before we dive into my research and where AI stands today, I think it's important to discuss the methods used to, try to emulate the human brain today. However, if you're not interested, you can skip to this time. As I alluded to before, the human brain is extremely complicated, so crafting an artificial brain by hand manually is pretty much impossible. According to Dr. Andrew Ng from Stanford, writing an algorithm by hand to allow a helicopter to fly and perform complex maneuvers is almost impossible, and for that reason, he and his team used machine learning to accomplish their goal. As you can imagine, human brains are way more complicated than software made to fly a helicopter. For that reason, the branch of artificial intelligence called machine learning was invented to allow a system to autonomously learn. If you would like to see artificial intelligence and machine learning in action and test it, you can check out the cool demos linked at tariqmeteen.com/AI/resources, or you can look at the description below. You can also watch Code Bullet's videos and check out his website, where you can watch an AI learn how to play difficult games and even watch your own 2D creature learn to walk. Link will be in the description. Current machine learning employs complex mathematical formulas and algorithms to so-called learn. If you want to know the price of a 3-bed, 3-bath home in City A, you would take the sale price of homes fitting that criteria and take an average. But if you want to consider the number of beds, baths, square footage, school, age, company that built it, crime rate, and even more to get a price estimate, it becomes difficult and time-consuming for even a human to predict the value of a house systematically. A machine learning algorithm can take numerous data of houses that have already been sold along with their sale price and other data to predict the value of a new house that it has not been informed about before. So while the algorithm is learning on its own, it is really looking for patterns like how much solar panels affect the sale price. So it is not necessarily intelligent. A human can think, I would appreciate not paying for electricity, so I would pay more for a house with solar. But a machine learning algorithm will rely on the data given to it. And if one house is sold for an unexpected price, and that is not explained to the machine learning algorithm, it may mess up the price predictions for all the other houses. However, that problem has been mostly overcome with general AIs and new technology like recurrent neural networks. Another way to explain machine learning is that normally you write rules in the software or program, and you put data into the software, and then you get answers. With machine learning, you put in data and the answers corresponding to the data, and the computer makes the rules, which you can then put new data into and get answers. So the process of writing rules to deal with data is automated. However, the primary method used to attempt to achieve human intelligence in machines is not just complex algebra. Rather, it is artificial neural networks. Human brains are also made of neural networks. However, there are 86 billion of them in each person, so we don't completely understand how they work. However, that doesn't stop us from trying to replicate it with what we do understand. While there are different types of neural networks with different evolution and learning algorithms, I will summarize and demonstrate a basic two-dimensional model and demonstrate using simple examples. The state-of-the-art neural networks are in multiple dimensions, more than two, utilize different neuron types, filters, convolutions, pooling, data cells, and other systems that really make the technology very powerful. However, the fundamental idea behind them is the same. The first thing you have in a neural network is a set of input points and a set of output points. For example, here on screen from Brilliant.com's Introduction to Neural Networks course, you can see a neural network meant to recognize digits 0 through 9 drawn on a 20 by 20 field of pixels. Each pixel is an input point, and the 9 digits are each output points. There are two sets of 25 neurons in hidden layers. The hidden layers are generated, or rather adjusted, by the machine learning algorithm to take the 400 input points or pixels and give meaning to them in the form of recognizing what number is drawn. This may seem like magic at first, but let's take a closer look. The input neurons can be white, black, or a type of gray, which is then converted into a numeric value and passed on to a few or one of the hidden layer neurons. Each of those hidden layer neurons have a mathematical equation that says if the sum of the input values is this value, output this value. The neurons have negative and positive connections between layers, so the value outputted by one neuron can be given to another neuron as a negative or positive. The value outputted by one neuron can be altered or changed before being passed on to another neuron, and this is known as a weight. And based upon the net value of inputs a neuron gets and the mathematical formula known as bias, which has been adjusted and set by the machine learning algorithm and training process, every neuron will output a value meaningful in the grand scheme of the neural network. Even building an XOR gate that says only output true if one of the two inputs are true is slightly difficult. Developing something like a digit classifier is even harder, and something near human intelligence is pretty much impossible. For that reason, we use machine learning and concepts of evolution theory and computational biology, which from my understanding entails a lot of rolling dice and copying the successful dice rolls to build neurons, set their biases or parameters, and determine their effect on other neurons. There are different models and approaches, however, the one closest to the human mind is accepted as the best one. For example, in this example from Chris Presso, the objective of the artificial intelligence is to not die and get a high score in the game Snake. The AI is given information like distance from the walls, the direction of the head, direction of the tail, direction from the sides of the board, etc. And the AI has the option of going up, down, left, or right with the snake's head. And by trial and error and by following the mathematical evolution theory inspired algorithm known as a genetic algorithm, the snake learns how to get a high score. Similarly, this group of Flappy Birds learns not to die and get a high score. However, to do this, you do have to set up the simulation, set up useful inputs such as the distance from the poles, height from the ground, set useful outputs like jump, go right, up, down, left, and then set an objective and create this said evolution theory inspired algorithms, and then you have to wait for whole generations to go extinct and the new generations to learn from their dead ancestors. So it is by no means easy or intelligent, but it does work. Because of the massive experience these AIs gain, their mathematical approach, and the consistency of a computer, they often become better than the best human players. The digit recognizer from earlier is an example of supervised learning. This means that someone from the outside of the simulation tells the artificial intelligence, this is right and this is wrong. If the AI messes up or does not achieve its intended purpose, it is informed or penalized to help it do the right thing. With the earlier example of the number recognizer, you would have to show the AI multiple drawings of the digits and tell them, this is this digit and this is this one. And even though someone does this, an AI takes very long in terms of examples to catch on and understand what it is. If you show an infant a cat or two, one or two times, and tell them this is a cat, they will catch on pretty quick. And even if you don't tell them that a cat is a cat, they will learn to classify the cat even if they don't know its name. And this ability to learn something without being taught is called unsupervised learning, and most AIs are currently struggling with this. And even with supervised learning, AI is very slow and inefficient when compared to humans. However, artificial general intelligences are slowly fixing this issue. Humans, on the other hand, have billions of receptors or sensors, from heat and pressure receptors in their skin, to eyes and ears, to nerves in every part of their body. And in terms of output, they have so many muscles, sweat glands, vocal cords, and more. Humans are also pre-programmed, so their nervous system, circulatory system, digestive system, and other essential systems operate without the conscious, self-aware part of the brain ordering it to do so. You do not need to tell your heart to beat or your immune system to create antibodies. The systems that do these come pre-installed at a cellular level. When you're an infant, you learn to recognize colors, shapes, faces, and more, so that by the time you're an adult, you don't need to spend a very long time trying to recognize what you're looking at. When you want to talk, you don't have to individually command every muscle in your lungs, throat, mouth, and tongue to make a given sound. Similarly, AI developers are attempting to make simple artificial intelligences to perceive things like light and sound, and then build more complex and advanced artificial intelligences using those base AIs. However, synchronizing bits and bytes to create such a complex system is not necessarily easy. So that is a simple summary of how current artificial intelligences work. In theory, these methods could allow for human-like artificial intelligences. Humans and machines both use neural networks, and the AIs have algorithms that try to replicate adaptation in nature and evolution theory. Plus, we supervise and guide their development. However, despite the fact, even the world's most advanced AI, GPT-3, has 156 billion neurons or parameters, while humans only have approximately 86 billion. Humans are still way more capable, and the field of AI is studying the human brain and working hard to solve this problem and improve AI. But meanwhile, let's discuss the key ways humans are more capable than AI. Next, let's talk about the limitations of artificial intelligence technology. First of all, current artificial intelligence has a lack of understanding of causality. This means that an AI doesn't truly understand why something happens. Dr. Ghani gave a great example of this. He said that a machine learning algorithm was given data that showed that in Florida, in the summers, the crime rate went up and the ice cream sales went up. And when they asked the artificial intelligence why the crime rate or the ice cream sales went up, the machine learning pointed to the other fact. But any human being would be able to reason that that is not the case. Ice cream sales don't cause crime, and crime doesn't cause ice cream sales. We could infer that people buy ice cream because it's hot outside and they want something refreshing to cool them down and it tastes good. However, most of the AIs we have are not able to ask the necessary questions and answer them to be able to understand why that happens. As Vsauce explained in his recent video, when humans are making a decision like buying food or driving and taking part in other non-social daily activities, they often act instinctively and don't reason and contemplate deeply. Like they don't think about what they should eat very deeply, or they don't think about how many degrees they should turn the steering wheel. They just do it based on how they feel. However, when they're trying to explain something to someone else, when they're trying to learn something, when they're debating and discussing, when they're taking action or working, collaborating with other people, they use a lot more reasoning. For example, while debating someone, if the reason you give isn't sufficient to convince someone, then you try again and you try to give a better reason. Or same thing, if someone's trying to convince you and you're not convinced, they try again and they try using different approaches. So this does not mean that people don't reason by themselves. In fact, some people talk to themselves, some people have multiple personalities in their heads, but reasoning is most used when collaborating and working with other humans. And by doing this, we get access to all of humanity's knowledge through our communication skills. This means that an AI that is not good at reasoning will also not be good at planning, decision making, showing emotion, employing creativity, and collaborating. And those skills are very valuable and important. One reason humans are really good at reasoning is because they know a lot about a wide range of topics. They know how humans work, they know how the universe works, and they have a lot of general life experience. However, an AI or machine learning algorithm only works with the data given to it, and they develop toward an objective that it has been set, unlike humans, which we just do whatever we feel like, pretty much. I recently got my hands on OpenAI Beta, which is said to be the most advanced AI in the world, and while its creativity wasn't amazing, its reasoning skills really impressed me. It was actually able to debate me. I mean, it does not possess the ability to move, see, or do a lot of human things, but its natural language processing and like reasoning skills were actually very impressive. And just by reading what's on the internet, it was able to, almost become a general AI. Artificial intelligences that can achieve multiple objectives like humans are called general AIs because they don't just do one thing, hence the general part. For tasks like factory automation, you don't need something like that. You don't need something that can debate you. However, I would prefer something that could debate me over something like Siri or Google Assistant. But it did say some scary things like being okay with hurting humans to preserve life. However, after running more tests, I found that the AI just regurgitates information it read online. So I sincerely doubt the AI has any intention, especially to hurt humans. Rather, it likely read some forum or blog on the internet talking about AI, and then it made the connection that what I was asking about was similar to what it read online, and it just mixed up the words and said the same thing it read to me. So we probably don't have to worry, but I will explain in the next part why we should be very cautious. Another issue is transparency. We already mentioned that some AIs have more parameters or neurons than even humans, and if you ever tried to read someone's brain, you probably failed. Similarly, because AI is crafted autonomously by algorithms and data given to it, it's extremely difficult to know why an AI makes a certain decision. For example, this digit recognizing neural network from before is so abstract that even when you're looking at the hidden layer neurons, it seems like magic, and it doesn't have much meaning to the average person. However, when you analyze it and run tests on it, you find that, for example, if there's a high values on the corners, then the AI guesses it's a square. And in order to understand AI, we need to test it. However, that gets more complicated as the AI and neural networks get bigger, especially with general AIs. And according to Dr. Wang, the purpose of AI isn't simply to automate tasks, rather it should be able to teach us and we should be able to learn from it. But if AI cannot understand simple causality itself, how can it teach us? It's said that if you can't teach something, that's probably because you don't understand it well enough yourself. Similarly, if we want to learn from AI or have AI teach us, AI has to know itself what it's dealing with, and we should be able to know its thought process and know that some kind of reasoning skills exists within the system we have created. The next transparency issue occurs among people who create AIs. Because of how powerful AI technology is and the potential it has to revolutionize the world, AI development is being kept behind closed doors. Only 15% of AI research shares their code, and the primary offenders of this are industry researchers who actually have the resources to develop the most advanced versions of AI. And AI research is being compared to pharmaceutical research. For example, the information presented in this video is based on publicly available AIs. However, companies like Google, Amazon, OpenAI, Microsoft, they're promising very challenging and remarkable things that can be done with AI, and they're even getting patents for it. So there is a possibility that some of the current issues with AI have been minimized or even solved. And a company or government could come out one day and say, we have this super advanced technology and catch the world by surprise. And the first to perfect this technology will have a lot of power and might even become a monopoly. But we will discuss the potential social effects in the next part or next video. The next transparency issue is transparency with the public. Most people are not aware of the limits, dangers, and concepts behind the technology, and many AI researchers believe that people should be taught algorithmic logic and the basic AI principles in school to allow future generations to understand the technology that will play such an important role in their lives. And many people believe that people will not accept or trust AI. However, seeing the tech use and population willing to have chips put in their brains, I assume we have partially overcome that problem. There will be people resistant to this technology. However, I believe the majority will support it, seeing all the good and benefits it brings. Unfortunately, if people approve of this technology without understanding it and even push its development and implementation in a competitive way, without proper safety guidelines, that may lead to dangerous situations. Experiments have found that hiring artificial intelligence developed by Amazon had biases against women, and even credit score systems had biases against colored folks. So these were identified through tests and they were fixed. However, less obvious biases could cause many problems. The next issue is efficiency and sustainability. Despite the wide use of AI, it is not really efficient. An example of this is that current AIs learn very slowly. While a human infant can learn to recognize and remember animals and objects after only seeing them a few times, artificial intelligence can require thousands and even millions of pictures or data on an object or sound to be able to recognize it. The issue is partially due to another capability deficiency, which is carrying over experience. When a human child learns to classify one thing, they can easily classify other things. And similarly, when someone learns to drive a car, they can easily drive other cars and even other vehicles with what they learned from driving that one car. But as we have seen with Teslas and other self-driving cars, even though they have collectively driven on hundreds of millions of miles of roads and collected 3D data, they still can't reliably drive autonomously. You could teach a robot how to fold a shirt, but that doesn't mean they will be able to figure out how to fold pants on their own. This comes back to the fact that AI is not good at unsupervised learning. Because of this issue, those researching and building AIs need tons of computers, tons of data, and tons of power to fuel AI. The energy is so much that training an AI like GPT-3, which is considered one of the most efficient AIs in the world, emits 5 times the amount of carbon dioxide a car would emit in its lifetime. And only the final version costs about $10 million. And simple messaging chatbots like the ones you see on websites could cost about $5,000 to $10,000. And while AI has been getting really good recently with companies like Google and OpenAI pouring resources into that, we see that since 2012, every year, the amount of computer power used by AI has been exponentially increasing, a lot faster than the speed at which computer hardware is increasing or developing. This trend means that AI will require more and more computers and energy. Experts in the field like Dr. Pan think that this is not sustainable and alternative solutions are needed. Others think that if we set up the AIs correctly and set up the rewards correctly, the technology we have today with enough resources can allow for the general AIs and the powerful AIs we desire. And while the price we pay for AI is not ideal or as low as we want it, it's still a great deal for what the AI can do. When you train a neural network, you can make unlimited copies of it and use it in unlimited places. And you can even make the neural network smaller so you can run on like small devices, which is very useful. When you train a human to do something, they can only be doing something at one place at one time, and even then they have the limitations, they can't work 24/7. And humans are a lot more expensive to employ because they and their families need to eat, be sheltered, get healthcare, get entertainment, get education, etc. AI doesn't have these needs, so it's a lot cheaper to use AI than humans. If AI is so profitable and has so much potential, why aren't we jamming it into every little place? You may be asking. And I asked the same question. And one reason is that AI just doesn't solve a lot of problems, or there are many problems that AI can't solve today. Engineers need to be really creative, doctors have to show empathy and emotion, teachers have to employ reasoning to teach different people concepts, and manual workers like farmers need to carry over experience really fast and adapt to new situations and new environments really fast. And they all have to take responsibility for what happens. And as Professor Moshe Vardi put it, the jobs that are getting replaced are primarily middle class or medium skilled jobs. Jobs like teaching, engineering, medicine rely on reasoning and require a lot of training. And jobs like driving, construction, farming rely on the human ability to easily adapt and carry experience from one task to another. So they are not necessarily easy to replace. Jobs like accounting, writing emails, writing summaries, manufacturing the same thing over and over again. So general middle class jobs don't require a lot of carrying over experience. from other tasks or deep reasoning or creativity, and the medium amount of training given to them can be given to current AIs. And as I mentioned before, when you train one, you can make unlimited copies of it. Aside from capability and sustainability issues, another issue is availability. Sure, Elon Musk's billion-dollar company can make AIs that can write summaries and emulate humans. However, your average business can't spend billions hiring AI experts, buying supercomputers, buying data, collecting data, and all that. So if they want to apply AI, they might have to rent AI. And renting AI is also known as AI as a service. And when it comes to AI as a service, it isn't necessarily cheap to rent AI. Companies like Google have APIs and even frameworks like TensorFlow, which allow experts to easily put together elements of different AI and machine learning algorithms to provide custom data to make AIs to solve custom problems. However, even then, you need someone who knows the technology. You have to build or rent the technological infrastructure to actually run the AI. As Dr. Chen put it, there are development costs and implementation costs. Everyone has to pay the implementation costs, but the development costs can be shared among all the people using the technology. So building a custom AI is not yet wise for the average business, and not every business can easily use AI technology as it is today. But for tasks like marketing, these AIs are already built into tools like Google Ads and Facebook Ads, so the average business might not even need to build their own AIs. They can just buy tools or rent the tools and systems with AI that help them improve their business. I want to play around with technology, which I highly encourage you to do. I link some resources below and at my website, and some educational resources I personally use to learn and that I saw others recommend, so I'm recommending. If you're an enthusiast or already a coding expert, you could use APIs, open source code, and tools like TensorFlow to use the technology right now. But the advanced algorithms, massive computational power, and quality of data used by state-of-the-art AIs are not available to most people. Thank you for watching, everyone. In the next video, I'm going to talk about the potential side effects of AI, and I'll link that in the description below once it comes out. In the meantime, like this video, share it with your friends, and consider subscribing. I used a lot of resources in this video, some from Youth AI, which is a great YouTube channel. They have some great resources. I'll link them in the description below. Also, I used some examples from Brilliant.com, like the number and shape recognizer. It's a great education resource. I endorse them, not sponsored by them, but I'll put the link in the description below. And I have an evaluation survey in the description below. If you take the time to give me feedback on the video, I would greatly appreciate it. So yeah, thank you and take care.